Good afternoon, everyone. So we want to look at electrolysis. Um, Here it says that electrolysis is a process you need to be familiar with in GC chemistry, which is the same as CSEC chemistry. And this is the first of two quizzes on the subject. So you have a quiz basically. In electrolysis, ionic compounds are broken down, and note this, note carefully, note keenly, because what goes for chemistry in Guyana goes to chemistry around the world. Sodium would not change from the sodium in Brazil or the sodium in China or the sodium in Azerbaijan, right? Or the sodium in Jordan, right? It's all the same. They're all the same. Electrolysis, so will not change. There might be more sophisticated technologies used to carry out an electrolytic process, but the concept remains the same. So nothing changes. The same sun that shines in Guyana will also shine in Europe, right? So nothing changes. The good thing about it is that when you learn these things, you get to understand the concept and how wide it is. Good, let's move on. Now, ionic compounds are broken down, as we know that. It is essential for your exam that you know at least the basic definitions. What is an electrolyte? What are electrodes? What is the anode? What is a cathode? Ionic compounds, anions, and cations. And can you recognize diagrams showing electrolysis? So it is important that you, the individual, after you would have learned these things, you must be able to critically, and when we say critically, we're thinking or we're saying thinking outside of the box. So that if a situation comes up, presents itself, you know how to differentiate. Suppose if in exam you have these terms coming up, or differentiate between electrolysis and an electrolyte, and anode and cathode. 10 marks. That's an easy 10 marks for you. But more so, in the long run, you should be able to know these things in any situation, whether you're at high school, whether you're at university, or whether you're wherever you are. So these are the key terms that you need to know, right? You need to know what is an electrolyte. What I'm saying to you, an electrolyte is any solution, like copper sulfate or sodium chloride or hydrochloric acid, any salt in solution, that's an electrolyte. What are the electrodes? The things that go into the electrolyte, like the rods. You have copper cathodes and copper anodes. You have carbon and all these, and platinum and these things. What is the anode? The anode, in this case, is always a positive electrode. And you should have been, you would know what I'm saying, because if you look at a battery, if you look at a car battery that you put into the cars, or you look at a simple battery, you know, that you put into your torch light, whether it is a AAA or a AA or an A. When you look at them, you see that they have electrodes. You see that they have two things. If it's a 9-volt battery, and you can understand that the 9-volt battery is a little thicker, it's more kind of rectangle-like, but you see a part that looks rough and another part. One is a negative and one is a positive. But more so if you look at your normal regular size rocket batteries or your Duracell batteries, then you see the bottom is flat and the top has a bulb, basically, right? So you need to understand the concept there. One is positive, one is the negative. The cathode is a negative electrode. Now, if the anode is a positive electrode, obviously the cathode will be the negative electrode. Ionic compounds. What are ionic compounds? Like sodium chloride and potassium sulfate and calcium nitrate and all these various solutions. Anion. What is an anion? Anion is negatively charged, and that is why it might sound kind of wrong to you. If the anode is positively charged, then the anion, which is negatively charged, like your chlorine, your chloride ion, your oxide ion, your nitride ion, your phosphide ion, all these things will be attracted to your anode. Because why? Negative goes to positive. Then you have your cation. And note carefully that your cations are your positive charges, like your hydrogen ion, your sodium ion, your potassium ion, your rubidium ion, your cesium ion, your zinc, your lead, your silver, your copper, your gold, and all these things. They will be, because they are positive, they will be attracted to the cathode, which is a negative electrode. So plus goes with negative and negative goes with plus. Simple. Good. And can recognize, you must be able to recognize very lucidly, that means very clearly, what diagrams represent electrolysis. In other words, you should not only know to differentiate them, but you should be able to know to draw them. It's very important, very easy to. You should be able to work out what is produced at each electrode from the starting material. You don't need to learn each and every electrolysis, but knowing a few simple principles, such as the reactivity series, will help you work things out from scratch. Now, I'm really happy that these topics relate, and I would have searched the web to get things that can, relate to you. So if you notice, we are teaching in sync. We're not jumping around the syllabus. We're going from step by step. We're building all the time. And so we would have come off rates reaction, we come off energetics, we come off reactivity series and all these things. And so here it is that we're speaking now, going back to the reactivity series, because once you know that reactivity series, it will enlighten you more as to know which element or elements will be displaced easily in solution. Very, very easy. So here they're saying you don't need to learn each and every electrolysis. Now, some people will do that. That's not a problem, but it's your choice. But they're saying here, and I am agreeing with them, knowing a few simple principles such as the reactivity series. You see that? If you know the reactivity series, and that's what I highlighted to you before, they're saying it will help you work things out from scratch. Yeah, and there they have a diagram showing you what's going on. I can only look at these diagrams, but we need to get back to get work done to see for yourself what happens. Anyway, they say the substance broken down by electrolysis is called electrolyte. Yes, any substance that is broken down, like for instance, you might have HCl or NaCl or copper sulfate or whatever you have. Once they are being electrolyzed, it means they releases, so like sodium chloride will release sodium ions and chloride ions in solution. The water that is present will release H plus ions and OH minus ions. So you have 4 sets of ions. Good. 2 for positive and 2 for negative, always. Let's move on. However, if it's a molten compound like lead chloride, there's no water. So you'd only have lead ions and chloride ions. Nice. Let's move on. Everybody with me thus far?
Yes, sir.
Everybody understand thus far?
Yes, sir.
Nice, nice. Let's move on then. Electrolysis is carried out by dipping 2 electrodes connected to a DC supply into a solution of an electrolyte or a molten electrolyte. Now, DC means direct current. So therefore, where does that direct current comes from? Anybody?
Battery.
A battery. That's right. A battery, always. Direct current. So picture this in mind. Let's look at the picture to help you. You have 2 carbon rods, let's just see. It's not that clear for you to see everything, but okay, they have 2 beakers showing you there. And I guess in one beaker, you would have a carbon rod, but it's not clear. Okay, just picture this to me. You have 2 carbon rods. You take this out of a battery, 2 batteries. Now what you can do, you take 2 pieces of copper wire and you tie the top. You make a little rung, a little curve so that it can, or you wound it around the very tip of one of those carbon rods. And you do, for the next one, you do the same thing. And then what you do, you connect a battery to the 2 ends. So picture what I'm saying. You have your 2 rods, and each of those rods will have a piece of copper wire attached to the very top of them. And the top of those copper wires that you have, those are connected to the positive and negative terminal of a battery. Then what you do now is that you have, let's say, a solution of, let's say, maybe copper sulfate or maybe hydrochloric acid. Now, pay strict attention to what I'm saying. You gently ask someone to hold the battery, like above the solution or the beaker of solution that you have there, carefully, and you insert very carefully those two rods into the solution that you have. Everybody picturing what I'm saying?
Yes, sir.
Only one person hearing. Anybody else? Picture what I'm saying?
Yes, sir.
All right, I hope so. All right, good. So let me go it over one more time just to avoid any incoherencies, confusions. Now, you have your battery. You can use a triple A, a double A, or a single A. Some people might want to use a triple A, nothing wrong with that, or a double A, nothing wrong with that. Good. You have two pieces of copper wire. And what you do, you have your two carbon rods, which you would have taken out from another battery or two other batteries. And you take one of the copper wires and you run it around the top. You run it around the top of one of the carbon rods, and you do the same thing for the other carbon rod, and you leave the tips, and then you connect those two tips to the battery, the positive and negative terminal. Then you ask somebody to steadily hold that battery just slightly above, because you need to insert the two carbon rods into a beaker of, let's say, salt solution or hydrochloric acid or whatever have you. And so when they're holding it above, you're gently immersing the two carbon rods into the solution. Now, a number of things will start to happen. You will almost feel, because actually when you would have connected, and these are a new battery you're using, you will almost feel the wires getting hot, because why? Current is flowing. Remember, current is the flow of charge, and in physics, current is the flow of charge as well. So when charge is flowing, it means electrons are moving. And so what you will see happening in the solution, you might see some fizzing action, which says to you that the solution that is present, whatever you have, like the sodium chloride solution or the HCl solution, is actually disassociating, the ions rather. Remember, electrolysis is taking place now. And what is electrolysis? Is the breaking down of an electrolyte by the passage of an electric current through it. Now, you may want to take down this definition for me quickly. Remember, we're looking at electrolysis. So you may want to take down this definition for me. And you can take this down for me quickly. Electrolysis is the decomposition. The word decomposition means to break down. It comes from the word decompose, which means to break down, rotten, destroy, disappear. So it is the decomposition, and put in bracket, breaking down, put in bracket, breaking down, of an electrolyte, E-L-E-C-T-R-O-L-Y-T-E, electrolyte. What is electrolyte? You can put example, sodium chloride solution, hydrochloric acid solution, copper sulfate solution. There are any solutions then we're looking at, right? Or it can be the molten state, like lead chloride, molten lead chloride. Good. So, bypassing, right for me, bypassing an electric current, through it, Everybody with me?
Yes, sir.
Yes,
Good.
sir.
Everybody got good. So you want me to repeat it back, or that's it? It is the decomposition of an electrolyte. An electrolyte could be things like it could even be water, because we can split water to give oxygen and hydrogen. But anyhow, like sodium chloride solution, hydrochloric acid, copper sulfate, or even in a molten state like lead chloride. That's without water. It's molten. It doesn't have any water. By passing an electric current through it. Nice. So let's move on. Now, they say here what will happen, or a molten electrolyte, right? One electrode is attached to the negative side of the power source and the other to the positive. So remember, the battery has both negative and terminal. So that's how you're connecting it so that the electrons can flow. And remember this, electrons always flow. You may want to take a note of this. Electrons always flow from negative to positive. In fact, and this is applicable to when you're doing physics too. So you see how these things are interrelated. So I'm not just you're just not learning, not only learning about the chemistry aspect, but you're also integrating what you would have learned in chemistry to physics. Look the direct relationship. Electrons always flow from the negative terminal of a battery to the positive terminal. In other words, the negative side of the battery is the shortest side of that battery. So electrons always flow from the negative side, which is the short side of the battery, to the positive side, which is the longer side. You may want to take a note of that for me. Electrons flow from the negative terminal of a battery to the positive terminal of a battery. Right, so it flows from the negative terminal of a battery to the positive terminal of the battery. Now, do you have that?
Yes, sir.
Yes,
Good.
sir.
Now, when electrons are flowing from the negative terminal to the positive terminal, almost instantly, or I should say almost instantaneously, there's a fictitious flow of positive charge in the wire. So when electrons, the second electrons leave that negative terminal and traveling to the positive terminal, simultaneously, that might be a better word to use, a flow of charge, we call it a fictitious flow of electrons, are coming in the opposite direction. So picture it, electrons moving from the negative terminal, you can draw your arrow and going around to the positive, and at the same time, a fictitious flow of positive charge is moving from the positive now side of the battery to the negative side. Did you get that?
Yes, sir.
Did you get it?
Yes,
Good,
sir.
nice. Nice. So you may want to take this down for me. Fictitious flow of charge, a fictitious flow of charge occurs simultaneously from the positive terminal and travels to the negative terminal of the battery. And you can make a note of this for me. This fictitious flow of charge is an imaginary current, Remember, or let me tell you, this fictitious flow is an imaginary current. Now, why do we say imaginary current? In life, everything has to be balanced. If you don't balance yourself, then you can fall outside of your center of gravity. This is physics. You can fall outside your center of gravity and you will topple. Therefore, the center of balance acts through you, the direct center. If you tiptoe or go back too much, you can fall over or topple over. That is because what has happened is that you have fallen outside of your center of gravity. Likewise, in this battery, in terms of equilibrium, to maintain that equilibrium, that balance in nature, you should have an opposing force that balances things out. In other words, if there was no gravity, then everybody, all animals, plants, everything would have been flung into space because there's no opposing force. But because there's a force of gravity acting on us, even though we're exerting the blood pressure of our bodies, we're exerting a tremendous amount of force, we have to be stationary right here, right? So always remember that. Good, so that is why you have to have a balance. So that is what is happening in terms of the charge and the balancing. Good, let's move on. Are you seeing this?
Yes, sir.
Yes, sir.
Nice, nice, nice. In industry, okay, let's go on. In industry, electrolysis is used in many ways, and it's so true. One of the favorites of the examiners is the production of aluminum. Now, the good thing about it, and aluminum is very important, it's a very important element that we have today because it goes to the manufacturing of planes, pots and pans, and all these other things that you need, lightweight material, and it's very durable, right? But let's move on. Aluminum. So now this is something you will have to learn, and I will have to teach you this too. It is called the Hall-Uralt process. It's two people that came together, two men, two scientists that came together. That's the title is Hall, or Hall, as some people say, and the other one is Uralt, right? Process. Well, you need to know that. Other examples of the real-life electrolysis, but I'll tell you more about that process as we go on. Other examples of the real-life electrolysis are the production of sodium hydroxide and chlorine by the electrolysis of brine. Right, this is very important as well. Now, and the refining of the metal copper. So copper can be refined by using electrolysis. Aluminum can be refined by using electrolysis. Brine can be refined by using electrolysis. If you know the principles of electrolysis, plus these examples, you should cope easily with any question that you come across. In other words, once you understand the concept, once you learn electrolysis, there isn't any problem at all that you will encounter. And I'm going to give you 3 scenarios, right? How to go about understanding, knowing what will form, if it's a concentrated solution, based on if it's a dilute solution, and all these things, right? What will be displaced, what is preferentially displaced, and all these things. 3 rules, right? But let's move on quickly. The key to understanding what is happening during electrolysis is to remember 2 basic facts. One is about electricity. The other is about chemical bonding. So true. In life, everything around you is about bonding, is about chemistry, right? It's about something that occurs in life. We can look at the chemistry of photosynthesis. We can look at the chemistry of respiration. We can look at the chemistry of metabolism. We can look at the chemistry of digestion. Think of it. Life is all about chemistry, right? Persons might say, "Oh, you ever look at a movie?" And this is not talking outside of what we're saying, but you ever look at a movie and it's the chemistry between 2 people, or the chemistry, because life is about chemistry. Yes, biology is important. Physics is important, but every single thing in life is about chemistry. That is why they used to have a problem with scientists who are chemists, and they try to argue that, oh, physics is first and foremost, and physics is not. Physics is important, but without chemistry, nothing is important. Check it for yourselves, right? Anyway, let's move on. Good. The key to understanding what is happening during electrolysis is to remember 2 basic facts. One is about electricity, so true. The other is about chemical bonding. Firstly, keep in mind that electricity is a flow of electrons pumped along a circuit in one direction by a power supply. It's either a power pack or a battery. And like we just would have mentioned, keep in mind that electricity is a flow of electrons, right? Pumped around a circuit, a battery, in one direction by a power supply. So you set up your in third form and second form, or probably only fourth form, you would have done this. You made a simple circuit, or you would have made a parallel circuit, so you understand the concept there. And secondly, ionic bonding involves loss and gain of electrons. So in bonding, which is ionic, you either lose, and you have to lose if it's metal, and you have to gain, which is non-metal. So you understand the concept, what is going on there. Opposite electrical charges attract one another. So the positive ions in the electrolyte move towards the negative electrode and vice versa. That is why I told you from the inception that the anode, which is positive, will attract an anion, which is negative. So chlorine, chloride ion, oxide ion, nitride ion, phosphide ion, sulfide ion, all these ions that are negative will travel to the anode. Why? Because the anode is the positive terminal. They will attract, like on like poles attract, so they will attract. The cations, which are the copper plus ion, zinc plus ion, lead ion, iron ion, silver ion, sodium ion, potassium ion, you name it, positive charge, they will go to the cathode because the cathode is negative. Unlike poles attract again. Good. Positive ions are called cations, like I mentioned to you before. And so the negative electrode is called cathode, like I just would have referenced to you, because it attracts the cations. The positive electrode attracts the anions and is therefore called the anode. Remember, I told you that before. During electrolysis in solution, oxygen is usually produced at the anode as anions are very stable. Good. When a cation with this, and let me tell you something, that is talking about the water. See, if you have electrolysis of water, what you have immediately there, if it's water alone, you have hydrogen ions separating from the oxide ions. So the hydrogen ions will be separated from the oxygen ions to form hydride, H plus, and oxide. But when you have a solution like sodium chloride or copper chloride or copper sulfate in the same water, yes, the water is going to split to give you H plus ions and O2 minus ions, but also the electrolyte that you have in solution will split to give you the H plus ions if it's hydrogen chloride and Cl minus ions, or copper chloride, Cu, 2 plus, and Cl minus ions, 2 Cl minus ions. So it happens. Everything splits. Good. Let's move on. When a cation, okay, during electrolysis in solution, right, we said oxygen is usually produced at the anode and anions are very stable. Right, let's move on. That's the third paragraph there. When a cation reaches the cathode, one or more electrons are transferred to the cations here because they're fighting their best to see who is going to be preferentially discharged, who is preferred to be discharged, first and foremost, canceling out its positive charge. Most cations are metals, so when they gain an electron, they become metal atoms. Remember that. Here we go again. Most cations are metals, like copper ions or zinc ions or sodium ions. So when they gain that electron, they become metal atoms. This is for electrolysis, and are deposited at the cathode. So they build up at the cathode. What happens then depends on the reactivity of the metals and whether the electrolysis is being carried out in solution or using a molten electrolyte. So, like I referenced to you just now, if it's molten, like lead chloride, you don't have any other ions except for the lead ions and the chloride ions. But if it's a solution, like HCl, you would have the H plus ions coming from the water and the OH minus ions. Likewise, from the acid of itself, you'd have the H plus ions and the Cl minus ions. If you have a copper sulfate solution, remember the solution is the key because solution tells you it has water inside. So you have the H plus ions and the OH minus ions, and also you have Cu2 plus ions and the 2 Cl minus ions. If it's copper sulfate, the same thing, Cu2 plus ions and SO4 2 minus ions. Remember that once it is a solution, you would have from the water, you have to say from the water, the ions given off, which you know is H plus ions and OH minus ions. From the solution, you have Cu2 plus ions with its copper sulfate and SO4 2 minus ions. And any other ions, like sodium, if it's sodium chloride, Na plus ions, 2 Cl minus ions. Am I clear?
Yes, sir.
Okay, am I clear, everyone? If the electrolysis is being carried out in solution, hydrogen will be produced. You hear that? If the electrolysis is being carried out in solution, remember solution, I just mentioned this to you. So it means it has water. You'll have H plus ions will be produced in the metal in solution. So let me go back. Hydrogen will be produced if the metal is in solution is higher in the reactivity series. Example, sodium, potassium. In other words, that might be a little confusing to you. Let me go back. If the electrolysis is being carried out in solution, hydrogen will be produced. You see that? If the metal in solution is higher in the reactivity series, such as sodium, potassium. So, in other words, it's one that is being preferentially discharged or displaced than the other. Less reactive metals will form a deposit on the cathode. And as the thickness of the deposit increases, some of the deposit will flake off and be seen on the bottom of the electrolysis vessel. Because they're less reactive, they cling on, but then they fall to the bottom of the beaker, whatever container you have, whatever vessel you have. And that's it. They stay there. See, it is visible. Good. Electrolysis, I'm sorry. In a molten solution where water is not present, like I said to you, the metal atoms are always produced. That is how reactive metals like sodium and potassium are extracted from the ores. So because they are not present in any solution, that's how you'll go about extracting them from the ores very easily. Very easy.